Okay, so I wanted to take an opportunity just to work some T-table problems with you and discuss when we use the T-table. In Chapter 8, we are going to be looking at confidence intervals and T-tests. And so when you take Statistics 2, you're going to start with Z-scores and then move into T-table or T-test problems. And with the T-test, you are going to use a different table. And we use the T-table, which is this, when we're using a normal distribution when you have a sample standard deviation, or when your sample size is smaller, generally 30 or less, or under 30, we use the T-table. Now, you will have to calculate the degrees of freedom when you are doing this. And how we do degrees of freedom is we take the sample size minus 1. And that is with this particular column right here. So, for example, if the sample is 12, you would find in the degrees of freedom, you would say 12 minus 1 would be 11 as the degrees of freedom. And so you would come down to this 11 mark in the degrees of freedom. Now, for the sake of this class, we are going to assume that we have a normal distribution and these are two-tailed tests. That is what I'm going to be looking at with you guys. Two tails. So, for example, if it is a 95% confidence interval, you would, for the sake of argument, we're going to work a problem here in a minute, you would find 11 in the degrees of freedom, and then on the two-tail, you would come over to where you see T90. All right. You would look at right here, 0.05, okay? So this is where it has split the 0.05 into two tails, resulting in 0.975. So you would come down in this column right here, and that would be the confidence interval number that we use, okay? So we're going to work some of these problems, and we're going to practice using this table to work our problems and calculate the confidence intervals, okay? And let me get this erased. Whoop. Well, I'm making a mess, aren't I? Okay. So, going back to the problem, let's look at one. Okay, in a recent sample of 12 adults, showed the average screen time per day is 4.3 hours with a sample standard deviation of 2.33 hours. Construct a 95% confidence interval. So when you look at this, you see that it does have a small sample of 12. It also has a sample standard deviation. So that tells us that we are going to use the T-distribution table. So when we look at our critical value, which is what the first thing we're going to look for is the critical value of T distribution. Okay, first step. So you're going to calculate the degrees of freedom, which the degrees of freedom in this case are going to be 11 because 12 minus 1 is 11. And we're looking at 95% confidence interval. Remember, in this class, we're going to assume it's normal distribution, two-tailed test, okay? Now, when you come to the T-table, you're going to come down in your degrees of freedom. was 11. Okay? And two-tailed test, you're going to come over to where it is 0.05. So when you do that, your t-distribution value should be 2.201. So that is what I'm going to use for my problem. Okay? Now, the second step is you calculate the standard error. Now, if you haven't watched my PowerPoint for Chapter 8 yet, I recommend watching that before you watch this. So the standard error of the mean, you're going to take your standard deviation, 2.33, over the square root of n, which is 12. Okay? And that is going to result in 0.67 as my standard error. So this is my first step. This is my second step. My third step for the confidence interval is calculating my margin of error. So my margin of error is going to be done by taking my 2.201 times my standard error, which is going to result in a value of 1.47 as my margin of error. Then, to calculate my confidence intervals, what I'm going to do is I'm going to take my 4.38 hours, my mean, my average, and I'm going to add plus or minus my plus or minus my margin of error, which was 1.47. And so what I'm going to have here is my upper limit is going to be 5.85, and my lower limit is going to be 2.91. Now, how I calculated that, 4.38 plus 1.47 equals 5.85. My lower limit is where I subtract. So what does that mean? Well, if I was to look at this, my mean in the middle, and I have 0.25 in the tails here, my average screen time, my upper limit is going to be 5.85, and my lower limit is going to be 2.91. And if I polled 12 adults, 95% of them is going to fall in this range, okay? Between 2.91 minutes and 5.85 minutes. So let's look at another one. Okay, construct a 90% confidence interval of a sample of 21 people with a mean of 25 and a sample standard deviation of 5.2. So let's look at my critical value. And I'm encouraging you to work this with me rather than just watch me, because unless you're working it, it's not going to make sense. So you know your degrees of freedom is going to be 20 because it's n minus 1. So let's go back to our table. And if you look at your table for, let me change colors, for n minus 20, where, because you do want to subtract 1, it's not 21, it's 20, and you're accounting for error by calculating the degrees of freedom because it is a smaller sample. Now, our 90% confidence interval. So I'm going to look at two-tail, 90%, which is right here. And you should have, hang on a minute, I'm doing something wrong. Let me see what I'm doing. So you're going to come down and you should have 1 point, let's say sample of 21 people, 90%. And you should have 1.725. Okay? Now, when you look at this, you're going to come back and you're going to, your critical value is 1.725. My standard error is going to be 5.2, which is my standard deviation, over the square root of n, which is going to be 1.13. Okay? Next, I'm going to find my margin of error. Which is going to be found by taking 1.725 times 1.13, which is going to equal, let me just put it in my calculator real quick. So when you multiply this, you should get 1.949 or 1.95, okay? If you round up. Now, you're going to take that 1.95 and calculate the upper and lower limit. So when you look at your mean of 25, you're going to say 25 plus or minus 1.95. So your upper limit, you're going to calculate by saying 25 plus 1.95, which is 26.95. And then your lower limit is going to be calculated by saying 25 minus 1.95, which equals 23.05. And what that tells us is, with our mean in the middle, your upper limit is going to be you're 90% confident that it's going to fall between 26.95 and 23.05. And that would look like this if you were to write it. You would have your mean in the middle. Which would be 25. And then your upper limit would be 26.95 and lower 23.05. And you are 90% confident that it would fall in this range, okay? And your margin of error, that yes. So with a margin of error of 1.95. So what does that mean? 1.95 is added here. 1.95 subtracted here. So this is negative. This is positive. Okay? Let's look at another one. So determine the margin of error for a 90% confidence interval with a sample of 20 and a sample standard deviation of 16. So my sample, you're going to say 20 minus 1 to calculate your degrees of freedom. So your degrees of freedom n minus 1 is going to be 19. Okay? Now, let's look at what this would be. So I'm going to find my critical value first. So I'm going to go to my t-test. And I'm looking at 90% confidence interval, degrees of freedom, 19. So 90 degree confidence interval, 19. So 19, and then 90 degrees, or excuse me, 90% confidence interval. So if I come down, let me just go back and look at it real quick. 90% confidence interval, sample of 20. So 19 degrees of freedom, and then two-tailed test. So it's 1.729, okay? 1.729. Now, that's going to be my critical value. So I'm going to next calculate my standard error of mean. This is done by taking 16 standard deviation divided by n, which is 20. And when I do that, I get 3.58 as my standard error of the mean. Now, if I calculate my margin of error, I'm going to take 1.729 times 3.58, which is going to give me 6.19. Now, what that means is to calculate my upper and lower limit, I'm going to add positive and negative. So it's telling me actually here just calculate the margin of error. It's not telling me to calculate the confidence interval. So my margin of error for this would be 6.19. But again, what is the margin of error? The margin of error is if you add 6.19 to your mean and subtract. This is the margin of error, what falls positive or negative between the mean and your confidence, what lies with your confidence level, okay? So 6.19 is your margin of error in this case. Let's look at number 4. To recruit new employees at the local country club, they would like to determine the average tips per day an attendant earns. The sample of 16 attendants averaged $42.60 a day in tips. Assume the population standard deviation for daily tips is $9. Construct a 95% confidence interval. So our critical value, the degrees of freedom is going to be 15, and the confidence interval is 95. So if I look at my degrees of freedom, erase this. My N was 16, so my degrees of freedom is going to be 15. Okay? And my confidence interval was 95%. So I'm going to come down, because I'm looking at two tails. I'm going to come down, and that would be 2.131 as my critical value. Okay? Now, I'm going to next calculate my standard error. Remember, that is your standard deviation over, and the standard deviation was $9, over N, which is 16, okay? And that gives us 2.25. Now, you're next going to calculate your margin of error. Let me erase some of this. So your margin of error is, you're going to take 2.131, which is my critical value, times my standard error. Which is going to give me 4.79. Now, if I take, if I'm looking at my mean, I'm going to come down here for room. My mean in this case was 42.60, okay, per day. And I have a 95% confidence interval, which is 2.5 on each side, okay? Because 5 divided by 2 is 2.5, okay? And it's split in the tails. So I'm 95% confident it's going here in this range. So with 95% confidence, my tips are going to be, if I add 4.79 and subtract 4.79 from my mean, it's going to fall between 47, 39, and 37.81. Okay? So with 95% confidence, it is falling in this area. Okay? Now, I hope you are working through this with me, because that, to me, the only way this makes sense is by doing it. Now, and this is going to be on the phone. Let's do another one. Construct a 90% confidence interval for a sample of 10 people with a mean of 85 and a population standard deviation of 20. Now, my critical value, we'll go to my t-test because I have a very small sample. My degrees of freedom are 9, because n minus 1 is 9, and 90% confidence. So 9 with 90% confidence. So 9, and then 90% confidence, because remember, we're going to stick with two tails. That is 1.833. Okay? So that is going to be my critical value. Now, I'm going to then calculate my margin of error. I'm just going to do MOE. And my margin of error is found by taking my critical value times my standard error. Yep, I did it out of order. Let me back up. We'll come back to this. Okay, so first things first, standard error. My standard error is calculated by taking my standard deviation, which is 20, over square root of n, which was 10, which is 6.32. Now, my margin of error is calculated by taking my critical value times my standard error. Okay? And when I do that, I get a margin of error of 11.58. Now, to calculate my upper and lower limit, I'm going to add my mean plus positive or negative margin of error. So let's look at it down here. My mean was 85, okay? And if I take 85 plus 11.58, I'm going to get 96.58. And if I subtract, I'm going to get 73.42. And with 90% confidence, it's going to fall within this range. So here I have 5% in the tails. Okay? So this is 90% of the range that it's going to fall into. What does that mean? Well, it means that 10% of the time, it is not going to fall between 73.42 and 96.58 because nothing is 100%. So 10% of the time, it's not going to fall within this range. So here's my upper limit. This is my lower limit. And this is my mean. Now, let's look at another one. And I guess I need to space this out more because I don't have, either I write too big or I don't have room. Okay, let's work another one. This is our last one. So here, a random sample of 21 NCAA men's basketball games in the recent season had an average attendance of 5,038 with a sample standard deviation of 1755. Using 90% confidence, calculate the confidence interval. Well, my degrees of freedom is going to be 20, and I'm looking at 90% confidence. So my critical value is first. So we're going to look at 20 as the degrees of freedom with 90%. So if I come down and do 20 and 90%, I get 1.725 as my critical value. Okay? Now, I'm going to calculate my standard error. My standard error is my standard deviation over the square root of n, which in this case was 21. Okay, so when I take 1755, my standard deviation, over the square root of n, I get 382.97. Now, I'm going to calculate next my margin of error. My margin of error is going to be found by taking my critical value times my standard error. Okay? And when I multiply those two, let me multiply it real quick. I get 660.62. So, when I take, to calculate my upper and lower limit, I'm going to take 5,038 plus or minus 660.62. So what does that look like? Well, if I draw it out, got my mean in the middle, and that looks a little skewed. Let's see. My mean attendance was 5038. And if I look at the upper and lower limit, I've got 660, 62 on each side. Okay, positive, negative. So if I add 660, I'm going to get 5,698.62 as my upper, and I'm going to get as my lower 4,377.38 as my lower. So it's going to 90% confidence it's going to fall between these numbers as average attendance. Okay, so I hope this helps with the confidence intervals, critical values of t-distribution, and standard errors of the mean. Well, if I can turn it off.